Welcome to Data Science 1, Probability, Counting Methods 1. All right, from the last few videos, it should be clear that counting is going to be very, very important. If you notice, on all the formulas that we've had so far, you have to count things in some way or another. So we need to learn some counting rules that will help us count through some of these odd events or possibly sample spaces that could be just dramatically large, okay? And we really need a way to do this. The first rule is what's called the multiplication rule. So if we have two experiments, E1 and E2, where E1 can occur in N1 ways and E2 can occur in N2 ways, then the combined experiment can occur in N1 times N2 ways. And let's look at this here real quick. An example. Well, we've already seen one of these. So when we had the dice before, we recall if we roll two dice, it's a combined experiment of rolling one dice two times. And if I roll one dice, this is the sample space. It's a dice with one facing up, a dice with two dots facing up, a dice with three dots facing up, the four dots facing up, five dots facing up, and six dots facing up. So there's N1 choices for my first roll. And for my second roll, it's exactly the same. So instead of listing out all the possible outcomes, I can just say, well, N1 times N2 is 6 times 6, which is 36. And that's what we had before. But last time I listed them all out. Okay, so here's another example. Almost all countries require motor vehicles to be registered with the government, and a license plate is issued. Suppose the license plate is written in the following form. So we've got a letter, digit, digit, digit. And we're going to use the English alphabet here. There could be other alphabets that you could use, but for right now, let's just stick with that. How many possible unique license plates are there? Now, this is also avoiding any situations where they could spell something that we don't like. Okay, so this can be viewed in the following manner. So for the first letter, I have 26 choices. That's how many letters there are in the alphabet. Okay, so the first digit is the second character in this. There's only 10 digits possible that we've been using. Here again, we have a second letter, which is 26, a third letter, which is 26, and then we have a digit again, and then another digit. So if I have all of these experiments, all I do is multiply the numbers together. So I have N1 times N2 times N3 times N4 times N5 times N6, which is 26 times 10 times 26 times 26 times 10 times 10, which is 17,576,000 possible outcomes. Now, who wants to list all those out? Nobody, but we can count them pretty easily without listing them all out. Okay? Now, this was with sampling with replacement. Means every time we ran across a new letter, we could use the letter again. It didn't matter. But sometimes you can't use the outcome again. So once you've used it, you can't do it again. And here's a simple example. You and I go to a trendy new cafe for tea. The waiter brings us a box of tea, and on inspection, we see that there are 7 tea bags, all of which that are different. Hence, if you have Earl Grey tea, then I cannot. And similarly, if I have mint, then you cannot, right? Because there's only one bag of each. So we agree to let you go first. So how many choices of tea do you have? Well, you have N1 equals 7 because you have a choice between all the bags that are there, all 7 bags. How many choices do I have? I only have 6 left, right? Because you've already taken one of the bags. So in this case, all we do is use our rule just like we've done before, and we have N1 times N2, which is 7 times 6. It's just 42 ways that we could have tea, where each of us has a flavor. All right, so here's a real quick summary. The multiplication rules allow us to count all possible number of outcomes without enumerating every single outcome. Sampling with replacement allows for an outcome to reappear in the combined experiment. Sampling without replacement does not allow for an outcome to reappear in the combined experiment. Hopefully that makes sense, because we're going to keep using these ideas. Let's go on to the next video.